Welcome to the Chapter 2.2 lesson video. Today we're going to talk about something called reference angles. Now, last lesson you talked about doing sine, cosine, and tangent of your 30, your 60, and your 45-degree angles. Now, we're going to talk about how this relates to other angles that occur as we rotate through the different quadrants. All right, so just to refresh, when we had a 30-degree reference angle, the opposite side was a 1, the adjacent side was a root 3, and the hypotenuse was a 2. When we had a 60-degree reference angle, the opposite side was root 3, adjacent side was 1, and the hypotenuse was 2. And we had a 45, 45, 90 triangle. Our adjacent side was a 1, our opposite side was a 1, and our hypotenuse was a root 2. Using this information, we could do sine, we could do cosine, we could do tangent of any of those angles. So being able to write something like this down and have it memorized is really important. You got to be able to do all of these things without a calculator moving forward. All right, if you could, please take out your notes. We're going to take some notes on some new stuff and how it relates back to these 30, 60, and 45-degree angles. All right, so our learning targets here, we're going to learn how to find what's called a reference angle given a certain angle. We can talk about how to find the exact trig functions using those reference angles, and we can find how to evaluate expressions using those different reference angles, and then find the measures of different intervals of function values. All right, so let's first talk about reference angles. Given any angle theta in standard position, there exists this angle also called the reference angle. The reference angle theta is the positive angle made between the terminal side and the x-axis. So in quadrant 1, the reference angle is just the angle. In every other quadrant, we have our original angle right here, theta. The reference angle is the acute small angle between the terminal side and the x-axis. It's always down to the x-axis, or in quadrant 3, it's up to the x-axis. Quadrant 4, it's up to the x-axis. So it's always between the horizontal and the terminal side. All right, so in quadrant 2, we go down right there. Quadrant 3, it's this angle back up to the x-axis, and quadrant 4, back up to the x-axis as well. Just be very careful that a very common mistake is to go to the y-axis. We don't ever go to the y-axis with reference angles. It's always the distance to the x-axis. So here's a couple problems. We're being asked to draw an angle, and then once we draw an angle, we're going to find the reference angle. So we're going to find that acute angle to the x-axis. So the first one isn't too hard, 218 degrees. All right, so we know that straight up is 90. 180, this is 270, so 218 is somewhere here in quadrant 3. So to find this angle back right here, to find theta prime, we know that we've already gone 180 degrees to get to this point, and we've gone a total of 218. So to get our angle there, we're going to go 218 and we're going to subtract 180 from it. 218 minus 180, that's going to tell us that our reference angle here is a 38-degree reference angle, because that's the difference between 218 and the 180 that it already took us to get to this point. So it'd take 38 more to get to here. Now the reference angle of 1,387, we have to do a little bit of work. We actually have to subtract 360 quite a few times. So we're going to subtract 360, subtract 360, subtract 360. Each time we're doing this, we're finding a coterminal angle. Now I've already done the math off to the side, so I know I need to do it 3 times. And when I subtract 363 times, I get 307 degrees. This is the least positive angle, so that's the one I'm going to want to use. So 370 degrees is going to be somewhere in quadrant 4. It's past 270 degrees. So our original angle already went all the way around like this. That's our original angle, and it wrapped around a couple more times, but it was coterminal with 307. We need to find our reference angle, this extra piece right here back to the x-axis, that reference angle. we need to find that. So we're going to go ahead and we're going to do 360 minus that 307 that was already traveled, and that's going to leave us with a 53-degree reference angle. So I'm not just coming up with these, there's actually formulas depending on what quadrant you're in, and this is something you're going to really want to take some time to copy down. So I would pause the video right now and make sure you copy down this graphic. What we have here is we have a big quadrant, and in each of the quadrants is a little quadrant of a reference angle drawn in that quadrant. So this is the quadrant 1 example, the quadrant 2 example, quadrant 3, and quadrant 4 example. In quadrant 1, so let's talk about just quadrant 1 first. In quadrant 1, the reference angle is your angle. The shortest distance back to the x-axis is just that angle that you've already traveled. So in quadrant 1, your reference angle is your angle. In quadrant 2, though, we've gone this angle, so we've gone this red distance right here. Our reference angle is the distance it takes to complete the trip to 180 degrees. So to calculate your reference angle, to calculate your theta prime, you're going to do 180 minus the angle that you've already traveled. In quadrant 3, it's similar, but a little bit different. We've now gone this red angle down here into quadrant 3. We want to find the angle back to 180 degrees, or how far past 180 we are. So we're going to take the angle, the theta that we've already traveled, and we're going to subtract 180 from it to figure out how far past 180 we've gone, and that'll be our reference angle. And then lastly, in quadrant 4, we're going to go ahead to find theta prime. We're going to take a whole circle, and we've already traveled theta of it. We're going to figure out how much more we need to travel to get up to 360. So this would be a really useful thing to have on a little piece of paper nearby when you're doing these problems. If you have an angle that's in quadrant 1, 0 to 90, it's just the same thing. 90 to 180, you're going to do 180 minus that angle. 180 to 270, you're going to do that angle minus 180, so similar but a little different. And then 270 to 360, you're going to do 360 minus your angle to get your reference angle. All right, so what we're going to have to do eventually is we're going to have to find the trig functions of these different angles. Now, we already know the trig functions of 30, 60, and 45-degree angles. So if we can find if a reference angle is a 30, 60, or 45-degree angle, then we can find the trig functions of these different angles. The only thing we really have to keep in mind is that in different quadrants, different things are positive and negative. So remember, in quadrant 1, everything is positive. In quadrant 2, sine and its reciprocals are positive. Quadrant 3 is tangent and its reciprocal. Quadrant 4 is cosine and its reciprocal. All right, so we're going to kind of combine our knowledge of special triangles and reference angles and put them into 4 steps. So if an angle theta is greater than 360 or less than 360, the first thing we're going to do, like we did on that one angle where it was 1,000 and something, we're going to add or subtract 360 to get us back to 0 to 360. We always want to be between 0 to 360. Our second step is going to be to find the reference angle. Once we've found the reference angle, we're then going to find the trig values of our reference angle. Now, these problems are going to be intentionally set up to be 30, 60, 45-degree reference angles. If it's another number other than that, you'd have to use a calculator. These are all problems you will do without a calculator. The last thing you're going to do, and this is something you should always do, people always forget it every year, and it always kills them point-wise, is you need to determine whether things are positive and negative. A number of you lost a lot of points on that last test because of negative signs on one of those problems. So positives and negatives are really important. So double check what quadrants you're in and what should be positive and what should be negative. So let's go ahead and let's do an example. The first thing I'm going to do is I'm going to draw my coordinates. I'm going to draw my initial angle of 210 degrees. So here's my initial side. 210 degrees is somewhere over here. So that's my 210-degree angle. I now need to find my reference angle. So I need to find this angle right here. All right, I'm going to do a little math off to the side. I'll do 210 minus 180. That is a 30-degree reference angle. So I now know for myself that what I have here is I have a 30-degree reference angle over here in quadrant 3. In a 30-degree triangle, my opposite side is 1, but I'm going down, so I'm going to make that a -1. My adjacent side is root 3, but since I'm going to go to the left, I'm making it a negative root 3. And then my hypotenuse is a 2. I can now find these 6 trig values here. I have everything filled out. I go sine of theta equals -1/2. Cosine of this angle is -√3/2. Tangent of this angle, and this angle is 210 degrees. So when I'm saying theta, I'm saying 210 degrees here. Tangent is -1/√3. So that's 1/√3 because the negative becomes a positive, which we simplify to √3/3. And then I reciprocate. So cosecant of theta is -2. Secant of theta is -2√3/3. And cotangent of theta is just √3. I'm lastly going to double check that last step. Make sure things are positive that are supposed to be positive. We're in quadrant 3. That tells me that tangent and its reciprocal are positive. The tangent one is positive. The cotangent one is positive. Everything else is negative. So refresh, what I did is I drew my picture. I found my reference angles. Sometimes I'll combine these two pictures into one thing. My reference angle was 30, so I drew a 30-degree triangle in quadrant 3, right where that angle was. My opposite side was 1, but I'm going down, so it's negative. My adjacent side is √3, but I'm going to the left, so it's negative. My hypotenuse is 2. Hypotenuse is always positive. I then did my sine, my cosine, my tangent, and reciprocated. All right, let's go ahead and find the exact trig values for a couple things here. So my first one I'm going to do is I'm going to do sine of -240. So sine of -240, I'm going to add 360 to that to get it back to 0 to 360. So sine of 240 is really saying I want to find the sine of 120. Those are the same angles in very similar places. They're coterminal. So I'll go ahead and I'll draw a sketch. A 120-degree angle is somewhere in quadrant 2. I don't know exactly where, but it's somewhere in quadrant 2. I need to find this angle right here. I know I've already gone 120, so I'm going to go ahead and do 180 minus the 120. That leaves me with a reference angle of 60. So I know this is a 60-degree triangle, so I might write a little 60 right there. I'll finish off my triangle. I'll label my opposite side √3 from 60. My adjacent side is 1, but since I'm going to the left, I'm making it negative, and my hypotenuse is 2. So the last thing I'm going to do is I'm now going to find the sine. So I'll look at my angle right here. My opposite side is √3. My hypotenuse is 2. So my sine of -240, back to the original problem, was just √3/2. And this is something you have to do without a calculator. This is how you show it without your work. You could just plug this into the calculator, but then when it comes time to show your work, you're not going to know how to show your work. Feel free to check with a calculator. That's totally fine always. All right, it's cosine of 315. I'll draw my angle. 315 is past 270, so I know that's in somewhere in quadrant 4 over here. So this was my original angle. I need to find my reference angle right here. To do that, I'm going to do a whole circle, 360 minus what I've gone so far, so minus 315. Remember, hint, they're usually 30, 45, or 60-degree angles. Sometimes we'll give you a different reference angle, but if I'm asking you to evaluate, it's going to be one of those. So that's 45 degrees, so I'll label that 45 degrees. Go ahead and finish off my triangle and fill some stuff in. My adjacent side is a +1. My opposite side is a -1 because I'm going down, and my hypotenuse is a √2. I'm then going to find the cosine of this angle. So the cosine is my adjacent over my hypotenuse. That is going to be 1 over √2, which we simplify to be √2/2. Now, a couple things I want to clarify. In quadrant 2, remember ASTC, sine was supposed to be positive. Sine was positive. In quadrant 4, ASTC, cosine is positive, cosine is positive. If I had wanted to find the tangent here, I would have had -1/1. Tangent's supposed to be negative. That's totally fine. Be very careful to pay attention to your negative signs. These problems like this, if you don't get those negative signs correct, you lose essentially all the points on the problem. All right, so here we have, this is very similar to our problems we did before when we did quadrantal angles. We're going to evaluate these and then we will then apply the squares, the times threes, the times negative twos, the squares, stuff like that. So we'll evaluate them first and that'll take just a second. So sine of 45 degrees, we can draw right here, that's a 1 root 2. So sine here, that's going to be 1 over root 2. And we're going to square that in a second, plus 3 times, and then 135. 135, that's somewhere in quadrant 2. 180 minus 135, that is also a 45-degree angle, so that's a 1, negative 1, since that's to the left, root 2. Cosine is adjacent over hypotenuse, so that's going to be 3 times negative 1 over root 2 squared. And then minus 2 times the tangent of 225. All right, so 225 is somewhere here in quadrant 3. We'll do 225 minus 180. This is also a 45-degree reference angle. My opposite side is negative 1. My adjacent side is negative 1. My hypotenuse is root 2. The reason those were both negative is because it was to the left and it was down. So my tangent here is negative 1 over negative 1, which is going to become a positive 1. All right, we can now square these things. 1 squared is 1. Root 2 squared is 2. Plus 3 times negative 1 squared is positive 1. Root 2 squared is 2. Minus 2 times negative 1 over negative 1, that's 2 times 1. So we have 1/2 plus 3 times 1/2 is 3/2. Minus 2 times 1 is 2. 1/2 plus 3/2, that is going to be 4/2 minus 2. 4/2 is 2, 2 minus 2, this is going to be 0. So our final answer is 0. This whole big long thing up here is really just a big long ugly way of saying 0. So being able to evaluate these reference angles, 45, 135, and 225, as all being 45-degree angles in different quadrants with different things being positive and different things being negative, is what allows us to evaluate it. We figure out what they equal, then we apply the things like the squareds, the times 3, the times negative 2s, the combining of all those numbers together. All right, last but not least, it says for an angle theta such that theta is between 0 and 360. So we're saying for some angle within our one rotation of a circle. Okay, so for some angle within one rotation of a circle, find all the thetas where the cosine of that theta is 1/2. So here's what we're going to do. This is kind of a creative problem. We have to work a little bit backwards. We're going to draw our quadrant, and we're going to ask ourselves a couple questions. First thing we're going to ask ourselves is we want cosine of theta to be a positive 1/2. Where is cosine positive? And this is why we always practice this. Cosine is positive in quadrant 1. Cosine is positive. Everything's positive in quadrant 1. Quadrant 2 is sine, tangent. Cosine is also positive in quadrant 4. So we'll draw our 2 triangles in quadrant 4. We then say, all right, cosine is my adjacent side. So this is a 1 over my hypotenuse, which is a 2. So then you ask yourself, what kind of triangle has an adjacent side of 1 and a hypotenuse of 2? Well, if it has an adjacent side of 1 and a hypotenuse of a 2, then that means that the other side, since we're using reference angles, is a root 3. And this one's going down, so it's a negative root 3. All right, well, if this is a root 3, then what angle is across from root 3 in those 30, 60, 45, 45 triangles? So across from the root 3, that means this has to be a 60-degree reference angle. This is also a 60-degree reference angle. Well, working backwards, in quadrant 1, a 60-degree reference angle means our original angle is, well, in quadrant 1, it's just the same. It's 60 degrees. In quadrant 4, though, a 60-degree reference angle, so if we go 60 degrees back from 360, that means this is a 300-degree angle. So we were able to work backwards and figure out that the cosine of 60 degrees is going to be 1/2, and the cosine of 300 degrees is going to be 1/2. These are the only two between 0 and 360 that will give us an answer of 1/2. All right, we'll do some more practice with these in class. If you have any questions before then, please feel free to reach out. Otherwise, I think you have enough information to get started. I'll see you in our next live session, and in the meantime, I hope you have a great day.